Great to see you here again in the next presentation. In this presentation, we are going to look a little bit deeper in the normal distribution. We will define the concept of the z-value, and we will use the z-value to calculate probabilities and percentages. And in the last slide, we will look at the service level, how we can use this graph, in fact, to determine service levels and define a service level agreement. You remember the normal distribution and the probability intervals. We have to remember, or you have to know, that the normal distribution is in fact a symmetrical distribution. It means that the left of the surface at the left of the average and the surface of at the right of the average, that they are equal. They're both equal to 50%. But what is also very important is to know that the surface between the average and one standard deviation is 34.1%. It's always 34.1%. The same between 1 sigma and 2 sigmas, it's always 13.6%. And at the end, we have between 2 and 3 sigma, which is always 2.1%. And then we have those ranges with the corresponding percentages of 68.2%, 95.4%, 99.7%. It means that when we have the average and we see average minus 2 sigma and average plus 2 sigma, that there are 95%, 95.4% of the values are between these borders. So that's very interesting to understand, and we're going to use that later, that property in the control charts. Now, let's have a look at the normal distribution and the z-score. Now, here we have the same normal curve, exactly the same standard deviation, but the average is different. Now, when we want to use this, when we want to calculate this, it may be a little bit more difficult, because when we consider the old way of doing this, there are a lot of tables, and it's very difficult to make tables for all values of the average, all values of the standard deviation. So basically, what has been done is that a number of graphs have been developed, but instead of building the graph around an average, we reduced the average to a value which is equal to 0. So basically, we're going to center everything not on the average, not on mu, but on 0. Now, basically what we want to know, the z-value is in fact showing that how many standard deviations there are between the average and the x value that we have. So in order to do that, we have to recalculate the x value relative to those standard deviations. And the formula is basically very simple, because we say that z is equal to the x, the value I want to measure, minus mu divided by sigma. Basically what we get when we have x minus mu is the distance between the average and the value I consider, and when I divide by sigma, I express that in the number of standard deviation. For example, x is the average plus 1 standard deviation. When we look at that, we find z is equal to 1. Now basically we can use this in the graphs, and we can read the numbers very easily. So we have graphs or tables showing the z values and the probabilities. So whenever we have an average, we have a standard deviation, any value we consider, we can express it in numbers of standard deviation to the left, to the right when z is positive, and to the left when z is negative. Now, when we look at the z-score, when we want to use it, we have to look at the classical graph, and it depends on the type of tables that you are using. So what we have, mu is the center. Now basically it has to be equal to 0, so we'll change it to 0, and we have the z-value. So what we know here is the percentage that we can read from the table is in fact as a function of the z value. When we know the z value, we know the surface between 0 and the number of standard deviations, which corresponds with the x value. And we also have, in fact, the knowledge that to the left of the 0 or the average, we have 50%. Now, based on this, we can then calculate what is the probability, for example, when we have to consider values smaller than a certain value of x, that x which corresponds with the z value. Now, the bell-shaped distribution is symmetric. So basically, we know at the left and at the right, that surface, at the left or the right of 0, we find that this is 50%. Now, when we have a table, we have to be careful. We have to see what are the values in the table. And when we see a z or table, and it starts from z equal to 0 equals 0, it means that the table is giving you the right-hand surface. So basically, that's what we find. In order to identify the probability that a value is smaller than a specific value, we have to take that value and add 50%. Now, there are other tables that give different percentages, and you see the graph below, and in this case, we don't have the surface between the average and the z value, but we have the total value, the total percentage of the surface to the left of that number. You can recognize this table when z is equal to 0 and we find the percentage to be equal to 0.5. Now we can use those tables. You can find it in some other documentation. And now we have to see how do we calculate those different surfaces. So let's have a look at some possibilities that we have. Now, what we want to know here, and let's assume that we have the table where z is equal to 0, so we only measure the percentage between mu and x. So basically we want to have the surface for x, the values smaller than x, so we have to divide that in two parts. First of all, we have the part left of the average, which is 50%, and then we add the surface between mu and x. So we get that out of the tables. Now, this is a little bit more complicated. Here I want to have the probability that a value is between, let's say, that we are between x1 and x2. So basically here we have to calculate the value for x2. So based on the top calculation, how we do it, we subtract then the surface for x1. So we also calculate that with the example that is just above. So these are different ways how to calculate these different elements. We will look at that in some exercise. Now here we have x at the left-hand side. With our classical approach, we measure the value between mu and x on the right-hand side. Now that's the same when we find the z value here, it will be a negative z value, but we take the positive value, and basically that positive value is the same percentage like the percentage that's missing at the left-hand side. So we take the 50% and we subtract the surface corresponding with that z value, but the z value now is positive. Let's have a look at the first exercise, and we also will combine it with Excel. This is the first element. We have a certain value for x, we have an average, and we want to know the surface to the left of x. Now I have different calculations here. I have different averages, different standard deviations, different values for x, but basically for all of them I can calculate the z value. The z value, which is x minus the standard deviation, x minus the average divided by the standard deviation. So when we take 35 minus 25 divided by 15, gives us 0.667. Now, when we look at that, when we find the surface, we find the surface which is equal to 74.76. Now, here we're using the decimal comma. In some applications, in some countries, this will be a decimal comma. When we have, let's say, in other countries, we will have a decimal point. But basically, you know what I mean here. We do the same for all of them, and we have those different Z values. We found the surface in a table, but we can also do it using Excel. Now, Excel offers these values, these formulas, and since we now have modern computers, everything becomes a little bit easier. We can use the normal distribution formula, where we have the x value, the average, and the sum, and then we have the parameter cumulative. So cumulative true means we will have the cumulative probability, and when it's false, we have the result for the density function. So basically, that's one formula where we just put x, mu, and sigma. We don't have to calculate the Z value, but we can do that. There is also norm S distribution. So we have the normal standardized distribution, and here we have the only parameter Z, because Z is in fact the only value that we need. And also we have the parameter cumulative, true or false. So when we look at the first exercise, norm distribution, I put the numbers in there. So x is 35, the average is 25, then we have the standard deviation, which is 15, and then we find the surface, which is 74.76. Now you have to be careful when you look at the Excel solutions. They always work with the second option, where we see when we put there Z equal to 1, we will find the 50%. So here we calculate the surface, all the surface left of x, including the left-hand side of the graph. The same thing we can do norm S distribution, and we put there the 0.667, and we say true, so it's also cumulative, and you see that we find the same value, 74.76%, which is in fact normal because they should give the same result. Now let's continue with another exercise. We have here a second exercise. Here we find the values, or we want to know the surface of x1, or the surface between x1 and x2. We have the same values for x1 like we calculated before. But now we also have the x2 values for the different applications. And when we look at the second example, we have an average of 90, a standard deviation of 30, x1 is 105, and we see that this surface is given by the formula. So we find here the correct surface, where the Z value is equal to 0.5, which gives us a percentage to the left of 69.15%. So I would normally find 19.15% plus the 50% gives us the surface, the total surface at the left of x1. The second thing we do, x2 is 130. Now we see that the Z value for x2 equal 1/3 is 1.333, which corresponds with the surface of 90.87%. And basically, to find the result, we subtract those two numbers, and we find that the surface between x1 and x2 is 21.72%. You can do this very easily when you are applying or you using Excel, or you can find it in the tables. But the tables, you don't need them anymore because you have Excel, of course. Now, when we look at it, we look at the percentage for x1. We apply the normal distribution, so we don't use the z values here. For the first value for x1 is 105. The 90, the average, and the standard deviation are the same, so I find the same value, and the percentage of x2 with the same basic formula, but now we put x2 equal to 130, which gives us 90.87%. And when we put when we calculate the result and we subtract those two percentages, we find the result like we had in the table, which is 21.72%. So basically, that's an easy way. Once you understand it and you want to do these calculations, it's always good to make a little drawing to see what you are actually doing. The third one is in fact where we have the x smaller than the average. So typically here we get a negative z value. So we take the same table, but now for calculation, we look at the lower row. So we have an average of 2,500, S is 150, the x value is 2,300. So when we calculate this, we find a negative z value, which is 1.333. So basically what we do, we use the table, we calculate or we find the z value for 1.333, or when we have the table where z equals 0 is equal to 50%, we can go to the directly to the negative z values. If we don't have it, we take the z value 1.333, which would correspond with like 40.87%, and we subtract that from 50%. So we find basically the 9.13% to the left of x. And when we go to the Excel, we can use both formulas, but the Excel formulas always give you the surface at the left of the value that you selected. So whatever you do, the formula gives you immediately the correct answer. Whatever value you put there, whatever solution you select, you always find the 9.13%. So that's basically the simplest way to deal with it. The other element is that we have other formulas in Excel that we can use. In fact, we have the normal and the standardized normal distribution. Now we calculated the percentage starting from Z or from X, mu, and sigma, but we can also calculate it differently. So once we have the percentage, we can also calculate the starting from the probability, we can also calculate the x value or the z value that correspond with it. The formulas are a little bit similar. Now we have x, and the input parameters are the probability, the average, and sigma. Those are the three elements we need here. And when we do the calculation for the z value, well, it's quite simple here because we only have to put there the probability and we automatically find the z value. Now let's take some of the elements that we had before. When we look at norm invest, or the 62.75%, we have an average of 35 and a standard deviation of 5. We find that the x value that corresponds with this is 36.6. Now, when we do the same with the, let's say, the z formula with the standardized normal distribution, we just have to put the percentage there, and we find the z value 0.32524. And with this z value, with mu and sigma, we can then calculate the x value. So you can use those formulas in different directions. The last thing I want to say in this presentation, in this video, is the service level. Now, when we look at certain elements, just imagine that you are looking at filling a cup of coffee and you want to be sure that you always have a certain amount, or you want to have a service and you want that service to be available for a certain percentage of the time. In fact, with those percentages, we can calculate what we call a service level. Now, typically, when you look at service levels, people define service level agreements. You have to be able to supply certain things in a certain time, or you need to have a certain safety stock. So these are elements that we can put there, but we can also define those service level agreement to say that we need to have the availability of the product, of the service, within or above a certain limiting or limit percentage. Now, we have to say that we develop those services in a way that we avoid claims and compensations. Basically, on quality, when we say we have to have a certain service level, we have to have a certain percentage of goods that are compliant. Our service has a certain percentage of performance. So these are examples of service levels. Now, we can look at certain elements when you have a specific service level. When we looked at AT&T, when we had data connections, those data connections were guaranteed to provide connection for a certain percentage of the time. If you wanted to increase the service level, you had to install, for example, a backup connection. And also, for example, when you have an airplane, one pilot is not sufficient. In order to have a certain level of reliability, you have to put there a second pilot. Now, these are all things that is in fact that are applied in certain applications, and that we will look into in other videos in the course of operations management or other courses. Another thing that is typical, and we will talk about it, for example, in the part of inventory, when we look at a safety stock, what is our safety stock that we have to foresee in order to guarantee, for example, the delivery of or the availability of parts with a certain percentage. So these were some elements about the use of the normal distribution, how we use the Z value and elements like that. It's a very interesting part because we will use these terms, we will use these calculations later in this presentation and in other parts of operations management. But these are also things which are very interesting for other subjects, for other applications. So you're doing a great job. I know you don't like statistics so much, but what I try to show you are the practical applications. So let's continue. Let's go to the next session, and I'm looking forward to seeing you there. Thank you very much, and bye-bye.